Let's talk about a globular cluster called Messier 68. Now, at first glance, it seems like a perfect, textbook example of a star cluster. But is it? Or is it hiding a really strange, anomalous secret that could completely change how we see our own galaxy?
There's a common saying among astronomers and stargazers when they look at these huge, glittering balls of stars. The idea is, well, they're all kind of the same. Beautiful, for sure, but ultimately a predictable sphere of ancient stars.
But is it really? The best science always starts by questioning the things that seem obvious. And when we zoom in on Messier 68, that simple little assumption, well, it starts to fall apart in the most amazing way. Okay, so to understand why M68 is so fascinating, we actually have to start with its history, back when it was famous for being completely, perfectly normal. First, let's just get our bearings. M68 is out there in the constellation Hydra, and it is a staggering 33,600 light-years away from us. It's just a faint little smudge in our telescopes, but it turns out to be a really critical piece of our galactic puzzle.
And this is really where its story as the poster child begins. About a century ago, the great astronomer Harlow Shapley used M68 as a sort of cosmic yardstick. He assumed it was just like all the other globular clusters, and by measuring it, he could figure out how far away it was. By doing this for a bunch of clusters, he completely revolutionized our view of the cosmos. He's the one who proved we're not at the center of the galaxy, but way out in the quiet suburbs. So M68's very boringness helped us find our true place in the universe.
But of course, the story doesn't end there. Not by a long shot. Modern astronomers, with way more powerful tools, started looking closer at M68, and they noticed something was off. The first clue came from what you could call its stellar family photo. Now, to see that clue, we need to understand this fundamental tool called a color magnitude diagram. It's actually pretty simple. You plot every single star's brightness against its color. What you get is this incredible snapshot of the cluster's life story, a distinct pattern that shows you stars at every stage of their evolution.
And here it is. This is the one for M68. You can see the main line of stars, the main sequence, still burning hydrogen. You've got the red giants over here, and this really critical feature right here, called the horizontal branch. These are older stars burning helium in their cores. At a quick glance, yeah, it looks pretty standard.
But when you put M68's family photo right next to one of its peers, like M15, the cracks really start to show. Just look at the difference. M68's horizontal branch is, well, it's weirdly lopsided. It's completely missing a whole population of very blue stars that really should be there. It's like a family photo where one entire side of the family just didn't show up. This was the first major hint that something was not quite right. Okay, so a lopsided photo is one thing, but the next piece of evidence, this was the astronomical equivalent of a smoking gun. It was something written into the very chemistry of its stars. So, when astronomers measured the elements inside M68 stars, they found something remarkable. Like its buddy M15, it's got a high amount of silicon that's totally expected for these ancient clusters. But look at the titanium. While every other similar cluster has a healthy, normal amount, M68 is shockingly deficient. It's almost gone. This is not a minor quirk, okay? This is a fundamental chemical fingerprint that just screams that M68 is different. So, what does this all mean? Well, it tells us that the gas cloud that originally formed M68 was seeded by a different kind of explosion. See, the elements in a cluster are basically the ashes of the very first generations of stars. M68's unique chemical recipe suggests it was enriched by ancient supernovae from stars that were maybe much, much more massive than the ones that seeded our own galaxy's native clusters. Its origin story is just different. A different family photo, a unique chemical fingerprint, all the clues are pointing to one pretty wild conclusion. M68 isn't from around here. It's a galactic immigrant, and it has a violent backstory. To get this, you have to know that astronomers basically split these halo clusters into two groups. You've got the old halo, which are the natives. They were born with the Milky Way, and they orbit along with it. But then you have the younger halo, and these are the immigrants, captured from smaller dwarf galaxies that our Milky Way ate a long time ago. They often orbit backwards, totally against the galactic flow. This chart plots all the clusters by their properties, and it just lays it out perfectly. The native old halo clusters, they form this clear, predictable line. But then, look at M68, that black circle, way off on its own. It doesn't fit in at all.
Its properties clearly mark it as a younger halo object. It's an outsider. So if M68 was captured, where's the evidence of the crime, right? Well, astronomers look for something called a tidal stream. When a small galaxy or a cluster gets too close to the Milky Way, our galaxy's huge gravity starts a cosmic tug of war, and it stretches and tears the smaller object apart, leaving this long, telltale river of stars in its wake. And that brings us to the final confirmation. Just recently, astronomers found it. A long, faint tidal stream of over 100 stars trailing away from M68. This is the proof. This shows us that M68 was born somewhere else entirely. It was violently captured by our galaxy, and that even today, the Milky Way is slowly, relentlessly tearing it apart. So we've seen M68, the perfect example, and we've seen M68, the strange outsider. Let's bring it all together and figure out the final verdict here. Which one is it? Is it the perfectly typical poster child that helped us map our entire galaxy? Or is it this unique anomaly that's rewriting our galaxy's history? Well, the answer is it's both, and that's what makes this story so brilliant. It was the poster child for Harlow Shapley because its assumed typicality was the tool he needed to unlock the sheer size of our galaxy. But today, it's the poster child for a totally different kind of discovery. Its anomalies, that strange family photo, its unique chemistry, its immigrant status, those are the tools we're now using to uncover the Milky Way's violent past of galactic cannibalism. M68 teaches us this amazing lesson, that sometimes the most extraordinary discoveries come from taking a much, much closer look at the things we thought were totally ordinary. And that just leaves us with a final thought, doesn't it? M68 was hiding in plain sight for 100 years. It really makes you wonder how many other perfectly normal stars, clusters, and galaxies are out there just waiting for us to look a little bit closer and reveal their own universe-changing secrets.